All right, so let's take a look at some of the other hormones that come out of the hypothalamus and regulation. So we take a look at egg and sperm production. There are actually several hormones that are involved with there. Again, we take a look at this and we see just a whole bunch of stuff. So let's follow the paths. Say we want to promote either sperm or egg development. That actually gets a little bit tricky. Notice that there's actually two hormones there, luteinizing hormone and follicle stimulating. And be careful, this is a pet peeve of mine. Whenever I do follicle stimulating, people, rather than listen to this stuff, they just Google it and they'll always come up with hair follicles. And so this is not stimulating hair growth. This is dealing with the egg and sperm production. So please be careful. LH and FSH is way different than people would Google search for. And yeah, they go the lazy way with it. So this is all, these two hormones are actually called for by the release of something called gonadotropin releasing hormone, GnRH. This asks for two separate hormones that will stimulate ovulation. And it's a little bit trickier when you talk about the menstrual cycle and everything. There's a difference between waking up eggs and then maturing them to be expressed later on. When we talk about sperm production, it's going to be the same story. We got to wake up these individual cells and then they mature and so on. So LH and FSH work together for promoting kind of sexual maturity of those sperm and egg cells. But there's also one that slows down that, and it's called gonadotropin inhibiting hormone. That's released by the pineal body, which is kind of like a solar panel. So we think about the pineal body is, when we have daylight hours and so on, we get into the winter blaws and so on, and that actually suppresses your sexual drive. And so the egg and sperm production is lower. But if we have times of good sunlight when spring comes around and so on, then all of a sudden this goes away because light itself will make this kind of be lower down. So darkness, it kind of slows down, increases this, and light would actually make this go away. Now, when we take a look at the overproduction, say the eggs are not working right or whatever, we're getting too quick of this or too slow of this, and so on. So there's going to be some of those different ones that go and regulate a hyper and hypo secretions. Now, light also plays another role outside of just the sexual cells and reproduction. With that way, we can also take a look at our just general day and night cycles. And so there's two hormones there, melatonin and serotonin. You hear about melatonin because people take it artificially to help them sleep. This is a mistake. If people are taking melatonin all the time to help them sleep, yes, it slows down, but what happens is your brain, basically the pineal body itself will say, oh, my melatonin is up and I want to maintain that balance, that equilibrium. So what happens is if you take this too much artificially, then what's going to happen is the pineal body will make serotonin to counteract and try to reestablish that balance. So those people that take too much melatonin every single night and do that to help them sleep, what they're actually doing is they're making the pineal body make more serotonin, which wakes you up. So it's a counteractive approach there. But when we talk about the pineal body in terms of light and dark interactions, we also bring in seasonal affective disorder. And this was identified late in the 80s. It's a hyposecretion of the pineal gland. And this is generally the seasonal affective disorder is one of those gentle winter blaws. People that live in the kind of the northern climates, we're very familiar with this. In the wintertime, we get cabin fever. We get a little bit off. We get a little bit more depressed and so on. That's because there's not enough direct sunlight. The pineal gland is actually not functioning enough. So to counter that, what happens is getting outside really helps, getting into natural sunlight. But what if you're not seeing those? What it's that really cloudy, really gloomy time of year and so on, not getting enough light. People would actually have, because you can't get, serotonin, you can't get injections of that or whatever. But sometimes they'd have actually phototherapy. Even though I'm not a big fan of tanning beds and so on, even going and getting into a tanning bed, getting that UV radiation exposure. They might even have, to some extremes, you have these kind of prescribed special lights that you get that actually are almost like grow lights, and that they would actually wake up the pineal gland. Okay, so hyposecretion, the pineal gland is just not regulating your serotonin enough, and so you would find those types of therapies getting out in the sun or simulating as much as possible to help regulate that again. Now, another thing that we could take a look at is specific metabolism. We've talked about in the thyroid gland, just general metabolism, but we have other types of other types of metabolism here. We might have aldosterone, kind of the metabolism of your sodium and potassium. You're supposed to have a certain balance of that, maybe specifically of carbohydrates. Maybe you also have, related to that, is going to be just general sex hormones, and they'll be androgens, is what they're called, but that'd be a male type, and they can be later on with a little bit of tweaking turned into estrogen as well. But we find that those three types of hormones come out of the adrenal cortex, which is why I had this picture. Remember the adrenal cortex, the adrenaline or suprarenal gland is up here above the kidney. Well, that is involved in this type of regulation. People don't realize that. So to regulate those three things, to get your sodium potassium pump to work right, to metabolize your carbohydrates right, or even to have your adrenal sex hormones, that all comes out of your adrenal gland. Okay, so to ask for that, the hypothalamus says, let's talk to that adrenal cortex, hence the name corticotropin, cortex feeding. Okay, so it's saying, okay, let's talk to that adrenal cortex. It tells the anterior pituitary, go ahead and start that process. And so the anterior pituitary makes ACTH, adrenocorticotropin hormone. Looks hard and looks really nasty, but it's just saying the adrenal cortex is being fed or nurtured, and so that's just the hormone that does that. So ACTH talks to the adrenal cortex and talks for three things. It boosts that sodium conservation and gets rid of the potassium. It boosts your carbohydrate metabolism, and it also makes those adrenal sex hormones. There can be things wrong with it. You can have a hypersecretion in what's called Cushing's syndrome, okay, which means that basically the body responds to this increased carbohydrate metabolism by depositing some fat deposits on the face. And this is a really derogatory term. They call it sometimes moon face or buffalo hump. This is the same girl within the span of just a couple months of these the abnormal fat deposits that we find in Cushing's disease. And this is going to be due to the hypersecretion of ACTH being a hypersecretion out of the adrenal cortex. Cushing's syndrome. Addison's disease is a hyposecretion, okay? And this is dealing with aldosterone. This is also dealing with cortisol. And so JFK had this. It's perpetually tan disease. We actually talked about this one when we were talking about the skin chapter, because they have bronzing of the skin. Now, that's not, the bronzing itself is just a side thing, okay? The staining of the gums, that dark stain on the gums and everything, that's just a sign. What's going on, you can't just say tan skin. That's not a disorder. But what's going on is this, because it's a hyposecretion, the adrenal cortex is not able to make that aldosterone. Even the carbohydrate metabolism is really slow and sluggish. So JFK actually battled with that a little bit in trying to get that metabolism, those specific metabolisms, up and running enough. Aldosterone as well as the cortisol, okay? So we find those are going to be characteristic of Addison's disease, hyposecretion of ACTH. Now, this is kind of a strange one because we don't think of the adrenal cortex as part of the reproductive system, but it is one of those things that adrenal androgens, okay? So we've got those. This actually is responsible for a hypersecretion in women of these adrenal sex hormones. And so this is actually a female with what looks like male parts because of a hypersecretion out of the adrenal sex hormones. Now, in guys, we don't typically find or recognize that because we have more of the male type hormones anyway. So you wouldn't really see adrenogenital syndromes show up. We would see instead the opposite, where maybe if you're not getting the testosterone enough, you're not getting enough of the male type features of hair, really thick hair, dense muscle mass, and so on. Maybe it's because the adrenal sex hormones are really low. Okay, so those androgens that come out is a hyposecretion, but adrenogenital syndrome is a hypersecretion. You tend to find that in female. Now, one more thing that I want to mention in this particular version or this particular lecture is the last of the secretions out of the hypothalamus, which have to do with water control, okay, the water balance, and also contraction of the reproductive systems. And so we've got two that actually are produced out of the hypothalamus, but they leave out of the posterior pituitary. There's no intermediate little hormone in there. It's not like the anterior pituitary where the hypothalamus made a hormone that talked to the pituitary, and then the pituitary would respond by doing something else. This is a hormone that's made out of the hypothalamus that just comes out of the posterior pituitary. So the first one we could talk about is the antidiuretic hormone. Anti meaning against, diuretics are things that make you pee. Okay, so if you have diarrhea, you have too much water excretion. Well, this is an antidiuretic. So the hypothalamus makes this hormone that comes out of the posterior pituitary that says, save your water. Okay, don't excrete your water. So if you have too much of that, you can't. You're storing all your water. You have water retention. If you have too little of this, then all of a sudden you're urinating all the time. You can't save any water. Now another one that comes out of the hypothalamus. That leaves through the posterior pituitary is something called oxytocin. You might hear about that when you hear about somebody that's been induced in labor. Oxytocin is one of those things that causes contractions of the reproductive systems, ejecting the milk, ejaculation of sperm. Now, this is one that actually has a positive feedback system. Remember I said the hypothalamus is responsible for reading the blood chemistry and saying, okay, if the levels are right, I'm going to do this and adjust. Well, here's one that's a positive feedback system with oxytocin and saying, okay, I'm going to ask for a little bit of maybe uterus contraction. Okay, you're going to start labor and it's going to contract the uterus just a little bit. And the brain, the hypothalamus, has to actually recognize that the uterus has responded. And so if it recognizes that the uterus responded, then it'll make a little bit more and say, okay, good, you're listening to me. Here's a little bit more oxytocin. I want you to contract a little bit further. And so if the uterus contracts, it gets that feedback and says, okay, now I want more. And so it's a gradual building up system for contracting, a much more safe environment for childbirth and everything else. Now, there's a interesting side kind of effect of having epidurals. Okay, epidurals are those things that you have injections to actually make the pain of childbirth way less, a lot more pleasant of an environment. However, what can happen if you have an epidural is actually slows down labor because it blocks that stimulus back to the brain and saying that the oxytocin is working. So a lot of times if you have an epidural put in, yes, the pain is blocked and everything else, but it slows labor down because the brain is not making that message. So a positive feedback system is part of it. If you induce labor, this is what they give you, a little dose of oxytocin to let the body kick in. So let's take a look now at the antidiuretic hormone disorder. We have a type of diabetes called diabetes insipidus. There's no glucose in this one. So you see this graphic, when somebody is going to be urinating a lot, the question is, do they have diabetes insipidus or diabetes mellitus? Because both are symptoms. Okay, diabetes mellitus is that one that we think about with the pancreas. Okay, it's not a brain disorder, but it's you basically peeing out all your sugar. Hence this little cartoon here. You got to taste it. Is it sugary? Is it sweet? Well, if there's no sugar in your urine and you have all these symptoms of urination, well, then you have diabetes insipidus, which means you have an antidiuretic hormone disorder, hyposecretion. Because remember, ADH says don't pee, conserve your water. Well, if that message is not there, that's a hyposecretion and it's called diabetes insipidus. Okay, so you got two different disorders that we talk about. Hypersecretion just means water retention and you can't actually urinate and so on, so that could be a problem too. Now, I've got this built into the PowerPoint because I want you to start thinking about what could this test look like? What are some of the things that are there? And this is built right in the PowerPoint so you can see this on your own. But here's the type of questions because I'm describing, name the hormone or the organ described, no abbreviations. You got to know the name of the hormone and so on. So think about this. I'm always talking about the overall function of the end product. Okay, so this is the one that's going to be talking about the cell size of the cell cycle. Here's one that asks for the stimulation of the secretion of hormones from the thyroid. Think about that a little bit. There's descriptions for those things. Secretion from the adrenal cortex. This hormone we just talked about reduces water excretion and so on. So think about this in terms of overall functions. Okay, name the hormone. Now here's some other ones. Okay, where does this come from? What are the glands? Maybe what are some of the causes of Graves' disease? Is it going to be a hyper or hyposecretion? You got to be able to name which hormone too. You can't just say it's a hypersecretion. You got to say hypersecretion of what. Okay, so be careful of those things and talk about, like, for specifically, acromegaly is a hypersecretion of which specific hormone. So that's the mindset that you want to be thinking about as you're practicing and reviewing, getting ready for the test. And don't worry, I've got the answers in there too. And notice that, like for number 7, any one of these is true. Okay, so you can do any of those. Hyperthyroidism as a condition could be caused by several different things. Okay, we're going to check back with you in part 3 of this series, and we're going to be talking about the hormones that are non brain triggered. So we're done with the hypothalamus. Now we're going to get into some of the other ones dealing with these.